Hi everyone, in this video I will show you how to solve this exercise problem. We will see exercise number 5 and number 6. So first of all, let's look at number 5. Write a program that converts a binary value between 0 and 15 into its ASCII representation. So what does this mean? So we need to look at to solve this problem, first thing you need to understand the problem. So you need to write a program such that if you are given a binary number, for example from 0 to 15, your program should be able to convert this number into its ASCII representation. So first thing you need to do is to know what is the ASCII representation for 0 and number 1 and number 2 and until 15. So uh, to do that, so you need to open the ASCII table. So to get the ASCII table, you can go to the internet and search for ASCII table. In this case, you can get from Wikipedia. So number 0, here, you look at the character CHAR here. So for example, for this symbol, so the ASCII representation is 27. So for number 0, okay, the ASCII representation is 30. The number 1, 31 until number 9 is 39. After that, for this symbol is 3a and so on. So we are interested in this part, which is number 0 to number 9, meaning that from number 0 to number 9, okay, the ASCII number representation for 0 is 30, 31, not 31. Number 1 is 31 until we have 9 is 39. What about number 10? Number 10 in binary is 1010 or in hexadecimal is A. Right? So here is A to 15. In binary is 1111 or F. So that means if we want to change this to ASCII, so we need to go back to ASCII table and look for A. So here is A, or the value is 41. So this should be 41. B should be 42. C 43, and so on until F is 46. Right? So that is the idea. So if we clear on this, so now we need to find a relation between this number and this number. For example, 0 we have 31, 0 we have 30, 1 we have 31, 2 32, and 9 39. So you can see that the difference between this number and this number is actually 30 hexadecimal. All right. So for example, if you have 30 minus 0, so you have 30. 31 minus 1, you have 30 also. 32 minus 2, you have 30. Meaning that the difference between this and this is 30. Alright, this and this is 30. Okay, so for example, if we have in any register, or you are given any number in your register, for example R1, you have number 008 bit. Okay, if 32 bit, so you have to extend this to 32 bit. So this is 32, but we are interested in this 8 bit. So 00, our program should be able to convert this 00 to 30. If we have if we have 1 here, if we have 0, 1 here, so we should have 3, 1 after we run our program. If we have 2, we should have 3, 2. If we have 9, we should have 3, 9. Okay, so how to do that? Very easy, meaning that any given value in R1 to convert to its binary, its ASCII representation is to add R1 with hexa 30. So you have the ASCII representation in R1. Alright, but this is for number 0 to 9 only. What about A to F or 10 to 15? So 10 to 15, so we need to find the difference between this ASCII representation and the binary, the ASCII representation and the binary number. So for example, for 1, so what is the difference? For 1 minus A. So you can use your calculator or you can do manual calculation. So in this case, for 1 minus A, so we have 37 hexadecimal. So this is 37. So the difference is 37 hexadecimal. 37 hexadecimal. So for A to F, if we have R1, if we have, for example, so here is A, so our program should be able to convert this to for 1. If we have B, it should convert to for 2. If we have F, it should be able to convert to for 6. Alright, so that is the idea. Now how to write the program? So to write the program, of course, we need to plan our program by using a flowchart. So let's draw the flowchart for this. Okay, so let's start our program here. Start. And let's get values that we want to convert to R1. Okay, and first thing we need to do is to make sure that the number in R1 is in the range that we want to convert to. So in our case, we need to check for, all right, whether the number is between 0 to 9 or between A to F. Okay, so we need to check for this. And ASCII number is an unsigned number. So for this case, no need to check whether it is less or than 0 or not, because unsigned number, there is no negative number. So we just check whether it is more than 9 or not, or more than F or not. If more than 9, the number should be between this range. If less than 9, the number should be between this range. Okay, so first maybe we can check whether the number is between 0 to 9 or not. So no need to check whether it's less to 0 or not. So just check whether it's more than 9 or not. So how to check? So you can have the decision here and check whether inside art1 is more than 9 or not. Okay, so if more than 9, meaning that the number is maybe between this range or more than this. Okay, but if less than 9, for example, if this is no less than 9, so what we do? So if less than 9, so what we do is we will add the number with hex 30. All right, so here if less than 9 means that this path, so what do we do is we have art1 add with hex 30. All right, then after this should be done already. Okay, finished. But if the number is more than 9, if yes, meaning that the value inside R1 can be A, can be B, can be F, or more than F. All right, so we need to check again whether the number is more than F or not. So here you need to check with F whether the value inside art1 is more than F or not. Okay, if yes, more than F, so you should, right, should be done already. So it should be done here. Okay, if more than F should be done already. So finish means finish. But if less than F, meaning that the value must be more than 9 but less than F, or equal to F, meaning that the number must be A, B, C until F. All right, so what should we do if the number is between that range? So what we do is we add that value with 37 hexadecimal, and then should be done already. All right, so this should be our flowchart. Okay, so check again whether it is correct or not. So for example, if our number is 1, all right, in art1, let's see, in art1 we have 0, 1. So let's see what happened. 0, 1 in art1. So 0, 1 here. Is it more than 9? No. So what do? We add with 30. So we will have 3, 1, which is in art1, which is correct. If we have 2, also the same. We will go to this path and we will have the number that we want. But if it is more than 9, for example, our value in art1 is B, 0B. So it will check more than 9, yes. It will check more than 9, yes. So, and it will check again, is it more than F? No, because B is not more than F. So we need to do this. All right, art1, B plus 3, 7. So we will have 4, 2 in art1. Okay, which is correct also. So if the number is more than this, for example, we have 1, 0, which is more than F already. All right, So our program will check here more than 9, yes, more than F, yes, yes, so done, do nothing. So it looks like our flowchart is correct now. Next, we will see how to write the program for this flowchart in Kale. Alright, in Kale Microvision, so we can write our program based on the flowchart here. So first get value to R1. So let's say, for example, our value is in the memory. So we can get from the value from that memory location by using LDR instruction. So let's assume that the value is from memory location 2,100,000 hex. Yeah, so we can use LDR. Use R0 as our pointer. Uh, so this is our memory location that contain the data. So we want to get the data from this memory location to R1. So we can use LDR byte value, LDRB. So from the memory location pointed by R0 to R1. Okay, so now we get the value from the memory, the value that we want to convert to R1 already here. And now we want to check whether this value is more than 9 or not. So how to check? You can use the compare instruction, CMP, compare R1 with 9. Okay. Okay, so this 9 can be decimal or hexadecimal, so it should be the same. And if more than 9, we want to go this way, and if less than 9, we want to go this way. So if yes, more means that we go this way. So what instruction to use here? So let's go back to our notes. All right, the program flow with condition. So we have unsigned value hi, branch if unsigned higher bhi. So we can use bhi here for unsigned value. So bhi. Okay. So if higher than 9, so we need to check for other value, right? Check whether it is more than f or not. So maybe we jump to a new label. Let's name it check. Second check. Check 2. Okay. But if it is less than 9, so we will need to do this. So if less than 9, so what do? We add R1 with hexa 30, and after that it should be done. So we should branch to done. Okay, so let's say our done is here. Done, no operation, and just n. Okay, and where is our check 2? So can be here, check 2. Okay, So to check 2 is we need to compare again. So use CMP R1 with uh, R1 with hexadecimal F. Okay, you need to compare with F. Again, if more than this, so you can use PHI again. More than this, so you need to branch to done. So it should be done if more than F. But if less than F, we need to do this. So this should be ADDS R1. You add with 3, 7. All right. So this should be our program. Okay. Very simple and exactly based on our flowchart. Now let's see the result by using the debug. Okay, let's see. All right, so this is our program. So in the memory, so this is the data that we want to convert. So let's say we start with 0 and we should expect 30 in R1. So let's run the program. So you can run line by line or just run at once by placing your cursor here and click run to cursor line here. All right, so we have 30 in R1. If we have other value, for example, 3 number 5, so we should expect 3, 5 here. So let's, for example, reset the program, go back, and if we have number 5 here, and see what happened in R1 after we run the program. So again, we run until this 3, 5, so should this is correct. And if we have A or 10 here, A, so we should expect 4, 1 in R1 when we reset. Okay, we run again. We should have 4, 1. Run 4, 1. Yes, correct. And if we have F, so we reset the program and see again. So we should have 4, 6, right? Okay, run 4, 6. Okay. What if we have other value than 0 to 15? For example, we have 1, 0 or 16. Okay, 1, 0. See what happened. Okay, 1, 0 and run the program. All right, so we have 1, 0 unchanged, right? No change. If we have 2, 0 should be unchanged also because it is out of range already. Okay, reset and run to the line. 2, 0 unchanged. Okay, so that is number 5.